All right, looking at factoring when you have an x cubed. So before we get into factoring x cubes, I'd like to just remind you about our rule for a difference of two squares. These should be the pretty basic, pretty simple ones to factor. You know, the first one you're looking specifically, our rule for difference of squares is, it looks like this, where you have a squared minus b squared. You have two things that are squared and subtracted, difference of squares. Whenever you do that, your two factors end up being a plus b times a minus b. So all of these are examples of difference of squares. X squared minus 4, well, that's x squared minus 2 squared. So this factors to be x plus 2 and x minus 2. Same thing here. This is x squared and 9 squared. So x plus 9, x minus 9. Remember, the order of your signs technically doesn't matter. I personally like to put the plus 1 first. No real reason. This one, that's going to be a 3x squared and a 5 squared. So that's 3x plus 5 and 3x minus 5. The last one, 3 is not anything squared, neither is 300, but I do have a greatest common factor of 3 that I could take out first. But once I do that, what I'm left with happens to be a perfect square. So this factors completely as 3 times x plus 10 times x minus 10. So we have a similar rule for cubes. So the first thing is you might want to become pretty familiar with recognizing your perfect cubes. Okay, you probably don't know many of them off the top of your head. I personally think you really should know at least to 6. You should know at least 1, 2, 3, 4, 5, and 6. 7, 8, 9, I'll kind of forgive you a little bit. 10, you should definitely be able to know that one. Okay, for cubes, we actually have two different rules. We have our difference rule and our sum rule. Okay, so here's kind of the rule, just like I did the difference of squares at the top. When you have cubes, you have something cubed minus something cubed for the difference. So what I like to say is the cube root of this goes here, and the cube root of this goes here. That sign's going to stay the same. And then whatever this term is, you square this thing to go here. You multiply these two together and change the sign for here. And then the last one is this one squared. Okay? So the sum rule is pretty similar. Again, this has a plus sign in the middle. It's something cubed plus something cubed. So again, take the cube root to decide what goes here. The sign stays the same. You square the first one, you multiply them together, and you change the sign, and then you square the last one. Okay? If you FOILed this completely back out, or distributed it back out, those middle terms would cancel out, and that's how you would end up with something just like this, where it just has these two terms left. Okay, the same, different, always positive is another way to kind of remember your signs for this. Some people forget the signs. So the thing is, the first sign's going to stay the same. The next one's always going to be different. It's going to be the opposite. The last one's always going to be positive. So for both rules, same, different, always positive. Same, different, always positive. Okay? So let's look at a couple examples. I think really that's the best way to get into this factoring business. So this first example, this is a sum of two cubes. This is something cubed plus something cubed. That's an x and that's a 3. So our first term is just going to be an x plus 3. Okay? For your next term, it's just going to follow this sum pattern right here. The first part is going to be this thing squared. So that's x squared. The next one is going to be you multiply these two together and you change the sign. So 3 times x is 3x. It's going to be a minus 3x. The last thing is always this one squared. So 3 squared is 9 plus 9, and this has been completely factored. Okay. Something to note is that this part will never go further. If it would, we would have another rule for it, but it's not going to be able to go any further. Okay, so similar thing on the next one. This one is a difference of two cubes, okay, the minus sign. That's x cubed and that's 4 cubed. So again, your first term is just the cube root of both of those, x minus 4. Okay. Again, for your next one, you square this. You multiply these together and you change the sign. So that's going to be a plus 4x. And you square the last one, plus 16. Okay, notice negative 4 squared is still a positive 16. And our last term is always positive. Okay. This next one, notice that it is actually not a perfect cube as it is, but if you factored out the common factor, remember that's step one, every time we factor out the common factor first, then you're left with something that is a perfect cubed. So that's x cubed and 10 cubed. So again, you're going to have an x plus 10. For the next term, it's this one squared. Multiply them together and change the sign, and then this one squared. Okay. Note we should put our common factor back in front. Okay, same thing for the last one. This one actually has a common factor of 5. If I take out the 5, I'm left with just an x minus 1. Well, 1 is a perfect cube. That's 1 cubed. So again, first term is going to be x minus 1. Square it. Multiply them together and change the sign. Square it. Greatest common factor stays in front. Okay? So those are our examples off the front here. On the back, there's actually quite a few problems back here. A lot of these are reviews. So eventually, this is where we're headed into things that where factoring is all mixed together, and you have to decide which method you're going to do. Okay, this first one, well, that's a difference of 2 squares. I could take the square root of both of those, and they're subtracted. That's 2x plus 3 times 2x minus 3. Okay. The next one, those are perfect cubes, and that's an addition. So again, we actually just did this one on the front. That is the cube root. You square it, you multiply them together and change the sign, and you square it. Okay. This next one is actually also a perfect cube, difference of 2 cubes, follows the same pattern. So cube root, that's a 4x minus 1. Again, you square it. When I square 4x, that's 16x squared. Multiply them together and change the sign. Square the last one. Okay. Question 4 is back to just traditional factoring. What multiplies to be 49 and adds to be 14? That's 7 and 7. Okay. This next one, again, perfect cubes. What are you going to have to do first? Take out the common factor. Now you have a perfect cube. You can actually factor that further. I'm not going to, well, I guess I will. It won't take me long. 2, again, you square it, multiply them together and change the sign and square it. Okay. Number 6 we've done before. Check out number 7. It's a cube, and I could take the 3 out, but actually I could take more than just the 3 out. I could also take out the 3x squared. This seems to be one of it's the easiest method to factoring, but it also seems to be one of the most forgotten, is just to take out that common factor. So don't forget to do that. Okay. Question 8, back to just a difference of 2 squares. That's 4x plus 7 and 4x minus 7. Okay. Checking out question number 9. Okay. Perfect cubes. So again, cube root of both, that's 2x plus 3. Okay. When you do the second part, again, you square it. 2x squared, that's 4x squared. Multiply these together and change the sign. Minus 6x, square the last one. Okay. Let's look at another one that's kind of similar to that. What about question number 13? Okay. 13. Here's some more perfect cubes. Feel free to work those out on your own. This one is going to be 4x minus 7 for your first term. Okay, that's again just taking the cube root of both. After that, then again you square it, 16x squared, multiply them together and change the sign, square the last one. Okay. What about question 16? That's another x cubed. How do you factor this one? Again, step 1, take out your common factor. When I take out the common factor of 3x, I'm left with x squared plus 9x plus 20. I could actually factor that further. What multiplies to be 20 and adds to be 9? That's 5 and 4. Greatest common factor of 3x stays in front, and that is now completely factored. Okay? I'm going to call that good on this video.